Yes. Yes. So, whoops, going back. All right. So take a look at your data. I think 24 point, look at the numbers. 24.5 definitely is a better descriptor of a typical number here than 29. Okay? So let's graph it and we'll show you what the difference is going to be when we use the median as a good descriptor for center. So this graph is a little different than yesterday's. So I'm going to go into stat plots. I'm going to go into my number one stat plot, turn it on, and I'm going to do a histogram because that's not a nice graph for seeing shape. But I have all my data in list 1 and I don't have a frequency list in list 2. So list 2 needs to become the number 1. And it's the alpha key is already lit on this. You have to hit the alpha key and then hit the number 1, and then it'll give you a frequency of 1. If you didn't hit the alpha key, you would get a Y in there. You just arrow down and you hit enter when you're highlighted over the on button. So if I go up, I'm on, I hit enter, and now the on button is lit. On means we're going to graph it. We've turned this graph on. Okay. So now we're going to graph this and we're going to see what the distribution looked like. Okay. So let's just do a zoom 9. Let's do a zoom 9. And it's not a very good graph because the scaling is never good. But what do you see about this graph? It is skewed right. This graph is skewed right. It's not the best graph because the scale is lousy, but this graph is skewed right. When we have a skew in our distribution, we choose the median. Come on. You choose the median as your center. If it's skewed left, we choose the median as our center. If it's skewed, we choose the median as the center. Okay? Waiting. What? Okay. Your calculator's gone bad on you? Yes, sir? So, skewed right or skewed left, we'll use the median for the center. Can you give her a hand here? All right. Now, let's go back and look at our data. Let's go back and take a look. This is MPG. This is MPG data for some car, miles per gallon. Do you think that 130 is a mistake? They should have cars like that. It's not a Prius. Does the Volt get that kind of gas mileage? Oh, okay. It was a lie. Okay. Okay. All right. Um, so let's say that was a mistake. Maybe that was a typo. Maybe it was just supposed to be 13. Let's say that was a typo. Let's say that was supposed to be 13. Let's go back into your data and let's change that 130 to 13. Somebody made a typo there maybe. So arrow down to the 130 you put in there before and let's change it to a 13. Okay. Sure. Go. Let's look at the graph, but let's do another zoom. A zoom 9. Much more symmetric now. Okay. All right. So if my graph is symmetric, if my graph is symmetric, let's use the mean. Okay. And I just heard somebody say that that mean changed to what? 23.39. Okay. 4. I rounded. Okay. All right. So you go to Stat, Calc, 1var Stats, press Enter. Okay. 23.39. Nice. Okay. What happened to my median? $23.5. Why did it go down one? Oh, put it at the other end. Sorry. Sorry. Put it at the other end. Now I get it. Okay. Went down. Went down one because I put data at the other end. Okay. All right. Yeah, we're going to do a lot of calculator. All right. So the median, the median is called resistant to outliers. The mean is not. My median changed by 1 when I had that outlier and I had to change it back. My median changed very little. Changed by a value of 1. How much did yeah, 23.5 to 24.5. How much did my mean change when I got rid of that outlier? By 6. So the mean is very influenced by the outliers. The mean will get larger and larger as the outliers get larger and further away from the center. The median mostly won't change. You know, the change of one outlier doesn't affect it by very much. So the median is called resistant. The mean is called non-resistant to outliers.